All right, welcome to The Explainer. Today we are diving into a topic that honestly is one of the biggest things that separates a junior developer from a senior engineer, and that is large-scale system design. So imagine you're in an interview and you get hit with a question like this. It seems absolutely massive, right? A billion users. But here's the thing. There's actually a clear, structured way to tackle a problem of this scale. So yeah, let's just dive right in. So here's how we're going to do it. We'll walk through the billion user challenge itself, and then we're going to break it down with a proven 4-step framework, understanding the problem, proposing a blueprint, diving deep into the details, and finally making that final choice. This is the roadmap, folks. Okay, so let's talk about this framework. You know, these kinds of system design questions, they are meant to be big and open-ended. The whole point is to see how you think, how you organize your thoughts, and zero in on what really truly matters when you're faced with a mountain of a problem. And this 4-step framework, well, it's your lifeline. It gives you that crucial structure. Think of it like a roadmap that makes sure you're asking all the right questions right from the get-go, helping you build a logical solution step by step. And trust me, when you're under pressure, that is everything. All right, step 1, understand the problem. Now, the most critical thing you can do here is just stop. Seriously, before you even think about databases or servers, you have to ask questions. We need to nail down exactly what it is we're trying to build. So let's take our YouTube example. The first thing you do is some quick back-of-the-envelope math. And what you discover is pretty staggering. You're not just building a video site. You're building a system that needs to handle something like 50 million video uploads every single day. That number right there, that one number changes everything. It tells you the immense scale we're up against, and it's going to shape every single decision we make from this point forward. And a big part of this first step is separating out two different kinds of requirements. On one hand, you've got your functional requirements. That's simply what the system does. You know, users can upload videos, users can watch videos. Pretty straightforward. But then you have the non-functional requirements. That's how the system performs. Things like high availability, reliability, low latency. For something like YouTube, sure, the functions are simple, but these non-functional requirements, that's where the real challenge is. Okay, so we've defined our mission. Now we're ready for step 2, proposing the blueprint. Think of this like an architect, sketching out the high-level plan for a skyscraper. We're not worried about the color of the paint yet, we're just laying out the major components that will solve the big problems we just identified. And a really solid place to start is the API. Why? Because the API is basically the contract between the client, you know, the user's phone or browser, and our backend servers. A super common approach is using RESTful conventions. So you'd have an endpoint, maybe something like /API/v1/videos. A user could post to that endpoint to upload a video or get from it to watch one. By defining this contract first, it gives everyone a clear set of rules to build against. Okay, now this is where things get really interesting. We can actually map the huge challenges we have directly to proven solution patterns. For almost every massive problem in system design, there's a well-established architectural tool to fix it. It's like a cheat sheet. So take that high read volume, you know, millions of people all trying to watch videos at once. How do you solve that? With caching. You stick a super fast in-memory data store like Redis or Memcached right in front of your main database. It holds onto the data for the most popular videos, which means you're not hammering your database for every single view. The result? A huge drop in load and much faster response times. And what about having users all over the world? You don't want someone in Australia waiting forever for a video that's stored on a server in Virginia, right? That's where a content delivery network, or CDN, comes in. It's basically a global network of servers that caches your big files, the actual video and image files, in locations physically closer to your users. It's a game changer for solving that latency problem. Now, for the database itself, we're probably going to lean towards a NoSQL solution. This lets us do something called denormalizing the data. Now, that's just a fancy term for storing related information together to avoid slow, painful database joins. So, for instance, we could stick the uploader's profile picture URL right inside the video's data record. Yeah, it's duplicating data, but it makes reading that data way, way faster because we get everything we need in one shot. Okay, blueprint's in place. Now for step 3, the deep dive. This is where the interviewer wants to see you really flex your engineering muscles. You pick one of the trickiest parts of the system and go deep, showing how you'd handle a specific, complex bottleneck. And for a YouTube-like system, the video upload process is the perfect candidate. As the quote says, Encoding a video isn't instantaneous. It can take minutes, maybe even hours for a big file. So yeah, this is definitely something we can't just do on the fly. It has to be an asynchronous task. And here's how you solve it step by step. The user uploads their raw video file. We immediately stick that raw file into some cheap object storage. And, this is the key part, we put a message into a message queue. This lets us instantly tell the user, yep, got your video. Then a whole army of encoding workers can pick up jobs from that queue, do the heavy lifting of encoding the video into different resolutions, and then save those new files back to storage. All of this happens in the background, completely separate from the user's experience. And when you do the math on this, the scale is just mind-boggling. Let's say we're handling 500 uploads every second, and each video takes, on average, a minute to encode. Well, that means you'd need about 30,000 parallel encoding workers. That's 30,000 machines all chugging away at the same time just to keep that queue from backing up into oblivion. That's a massive operational challenge. And that brings us to our final step, which is arguably the most important lesson in all of system design. It's about the final choice, or really, the art of the trade-off. Because here's the secret. There is never a single perfect answer. It's always about making a series of smart, well-reasoned trade-offs. A classic trade-off for a site like YouTube is availability versus consistency. Do you want the site to always be up, even if some data is a tiny bit stale? Or do you need every user to see the absolute most recent data, even if it means the site might sometimes fail to load? For YouTube, the answer is easy. You choose availability. It's way better for a user to see their homepage load even if a video uploaded 1 second ago isn't there yet, than for the whole page to crash. And you know what? This idea of trade-offs and evolution is perfectly mirrored in YouTube's actual history. They didn't start with some flawless, infinitely scalable system. They started with a single MySQL database. Then, as more people started watching, they added read replicas to handle the traffic. When uploads became a bottleneck, they started sharding, basically chopping up their database into smaller pieces. And eventually, that got so complicated that they built their own solution, Vitess, which is like a super smart traffic cop for their massive database. The point is, systems grow and evolve to solve the bottlenecks they have right now. So, here's the real takeaway. System design isn't about memorizing every technology out there. It's about having a solid framework to figure out what the real problems are. It's about understanding how to weigh the trade-offs, and it's about building a solution that isn't perfect today, but is ready to evolve for tomorrow. So as you think about your own projects, what's the biggest bottleneck you need to solve first? Thanks for joining me on this explainer.